So here we have the integral test, and it says that if the f of x is the function f of x is positive, continuous, and decreasing on the interval from 1 to infinity, then the corresponding infinite series converges if this integral, improper integral, converges, and the corresponding infinite series diverges if the improper integral diverges. And now we want to use the integral test to show that the harmonic series, the series 1 over n, diverges. In an earlier video, we have seen that this harmonic series diverges. But now let's use the integral test to show that it diverges. And so since the sequence is 1 over n, so we have a sub n is equal to 1 over n. And then the corresponding function, continuous function, is 1 over x. And for the integral test, we need the function to be positive, continuous, and decreasing. And this function right here, this is the function 1 over x. So this is what the function 1 over x, this is what it looks like. This is what the graph looks like. And so this is 1, and then we go into infinity. So we can see that from 1 to infinity, the function is continuous. And from here to here, the graph is above the x-axis, so everything is positive. And it's also decreasing. So we need the corresponding function to be continuous, decreasing, and positive. So we need those three things. And one more time, the integral test says that if the corresponding integral converges, then the series, the infinite series, converges. So now we need to form the corresponding integral. So we want to show that this integral right here converges. One to infinity, and then f of x dx, which is equal to 1 over x. And then for this type of improper integral, we normally write it like this. Let b approach infinity, and then change that to a b. So it would be the same thing. B is approaching infinity. So we have been used b for the upper limit of integration. And so now we have the limit and the antiderivative of 1 over x is ln of x. And we need to evaluate this from 1 to b. And so this becomes the limit as b approaches infinity. And then evaluate b, which is plugged in b here. We get ln of b minus ln of 1. And so as b approaches infinity, ln of b will approach infinity also. And ln of 1 is just 0. We get 0. So we get infinity. And so this integral right here diverges. And then the integral test says that if this integral diverges, then the series, this series right here, this series, the harmonic series, also diverges. And as we also saw in an earlier video, we saw that the harmonic series diverges, but we didn't use the integral test there. We used another strategy. But now we have used the integral test, and we've shown that the harmonic series diverges.